Hello everyone, welcome back. Let's talk about various features of the records. So I have listed all the features of the records and I will go through these features one by one. In a record, we can have different types of constructors, and those constructors can be canonical constructor, compact constructor, no argument constructor, and custom constructor. The canonical constructor is generated automatically in a record, and we can define the compact constructor to validate the components of a record. In a record, the methods like equals, hashcode, and toString are generated automatically, and we do not need to write these methods in a record. And based on our requirement, we can override these equals, hashcode, and toString methods. In a record, we cannot define the instance variables. The instance variables are not allowed in a record. In a record, we can define our custom instance methods. We will see later how we can create the custom instance methods in a record. In a record, we can define static variables and we can also define the static methods. In a record, we can create the main method. So we do not need to write the main method in another class and then from that class we need to execute that main method. Instead, we can create the main method in the record itself. I can create a record within an interface. I can create a record within a class and I can create a record within a record. The records are implicitly final and the records extend java.lang.record class. So, um, so the records cannot extend any other class, but the records can implement the different interfaces. And at the end, we will see how we can serialize the records. Here we have a record named order, and this order has four components named as order ID, quantity, product name, and price. And we do not have any constructor inside the order. This is a main class where I have created an object of the record, and using the accessor methods of the record, I am displaying the uh, components of the record. So I'm going to execute this. Yeah, so here we can see that the all components are initialized with the values that we have passed here. So in a record, a canonical constructor is created by default, and this canonical constructor is responsible for initializing the all components of a record. We can redefine the canonical constructor if we want. So I'm going to redefine the canonical constructor to perform the validation on the price and quantity. A canonical constructor is generated and now I'm going to perform the validation here. If quantity is less than or equal to 0, then it should throw illegal argument exception. and same validation we can perform for price. In a canonical constructor, after performing the validation, it is mandatory to initialize the components of the record. So these four statements are mandatory. So I'm going to execute the code, and here I'm passing the quantity as -1. Let's see what happens. Yeah, so here we are getting the illegal argument exception, and the message is the same that we have provided. But the way we have performed the validation in the canonical constructor, it doesn't look cleaner. So there is one more constructor in our record that we can use to perform the validation, and that constructor is compact constructor. So I'm going to copy this code from here, and then I'm going to remove the canonical constructor, and I'm going to generate the compact constructor. Compact constructor does not receive any parameters, and here we can write our logic to validate the components of the record. Now I'm going to execute the code again. Again we are getting the same error because here we have provided the quantity as -1. If I fix this, and now I have updated the quantity to 1, so it should not give any error now. Yeah, so here we can see the complete order information here. So in the compact constructor, after performing the validation logic, we do not need to perform the initialization of the components of the record. So it is much more cleaner way than the canonical constructor. Next constructor is the no argument constructor. So let's see where we can use no argument constructor. I am going to create a new class named server config, and this server config class would have two members named as IP and port. So instead of the class, I would create the record. So I have created a record named as server config, and here we need to define the two components, IP and integer port. Suppose I want to run my application locally. So when I run my application locally, then in the IP I can provide the local host or 127.0.0.1, and in the port we can provide the port number 8080. So in the local environment, I do not want to provide the uh, IP and port again and again, but in the other environments we need to provide the different IP and different ports, because that will depend on the environment. Here we can utilize the default constructor, and this constructor would not have any fields. And in a record, we cannot define the custom constructor unless we invoke the canonical constructor from within the custom constructor. So from within the custom constructor, I'm going to invoke the canonical constructor. So when I would run the application in the local environment, in that case I have to pass the IP as localhost or 127.0.0.1 and port number as 8080, and that would be fixed. Everybody in my team who wants to run the application, they do not need to specify the IP and port. Using this, I'm going to pass the localhost in IP, and in port number I can pass 8080. So we can directly create an instance of the server config with the no argument constructor, where we do not need to pass the IP and the port. Now let's talk about the custom constructor that receives multiple arguments. So in the order record, I'm going to remove the compact constructor. So from the record, I'm going to remove the compact constructor and I'm going to add the custom constructor. Okay, and for now, I'm not taking any field. Where we can use it. The custom constructor would be useful when we are receiving the mutable objects from the outside, and then from the mutable objects we can extract the values, and from within the custom constructor we can invoke the canonical constructor. So in the custom constructor we can get the order ID, quantity and product, and here product is a mutable object. So from within the custom constructor I'm going to invoke the canonical constructor, and I would pass the order ID, quantity, and then I would extract the product name from the product, and then I would extract the get price. So it is done. In the main.java, instead of invoking the canonical constructor, I am going to create an object of the product. Let me execute the code now. It's perfectly fine. This is how we can use the canonical, compact and custom constructors in a record. Now let's explore equals, hashcode and toString methods in the record. So in the record, equals, hashcode and toString methods are generated automatically we do not need to write these methods unless we want to override these methods. So let's verify. Here in the order record, we do not have equals, hashcode and toString methods. Now I'm going to open the main class and I would create another record and I would rename it to order record 1, and then I'm going to invoke the equals method. Yeah, so here we can see that its output is true because both of these records are having the same data. So now I'm going to update the data. Now we can see that it is giving value false because we have updated the order ID for order record 1. Let's verify the same thing for regular Java class. So in the order class, I'm going to remove this is the regular Java order class, which is an immutable class and it has constructor and getter methods. And from this class, I'm going to remove the equals, hashcode and toString methods. So I have removed it. Now in the main, I'm going to create an instance of the order. For now, I'm going to comment out the record code. So here we can see that it is giving the result as false even though the values in order and order 1 objects are same. This is happening because in the order class we did not define the equals method and it is taking the equals method from the object class, and in the object class the references are compared instead of values. That's why we are getting the value false. So if we pass the value as order 1, then it would give us true. Yeah, so here we can see that its value is true. Now again I'm going to uncomment the code for the record. So in the record we have equals, hashcode and toString method. So let me do one thing. Let me print the record object. And let me do the same thing for a regular Java order. So for the first one, we can see that the order class is printed with its complete package name and the hash code. But when we are printing the record object, it is displaying the data of the record. So we can say that the record has automatically generated the toString method. And I'm not going to check hashcode method here. And we can also override these hashcode equals and toString methods based on our requirement. So I'm going to override the equals method, because if I want to compare two different orders, then we need to compare the order ID only. We are not interested in matching the product name, its quantity and its price. If two orders are having the same order ID, then we can say that the both orders are same. So from here, I'm keeping only order ID, and same I'm going to have in the equals method. And I'm also going to override the toString method. And I want that whenever the object of the order record is printed, at that time only order ID should be shown on the screen. So I have overridden the equals hashcode and toString method. Now I'm going to execute the code again to see what happens. And here I'm going to compare two different order records. And I'm going to do one thing. I'm going to have the same order ID but different product name. So I'm going to rename it to product 1, and this is going to give me the order ID, because uh, this would invoke the toString method of the record. So I'm going to execute it. So here we can see that this statement from line number 16 is giving value true, because it is comparing the order ID only. Here we can see that the product name in both of the records are different, but it is returning the value as true because it is only comparing the order ID. And here we can see that when we are displaying the order object, it is displaying the order ID only, because inside the toString method we have written the code in such a way that it should display only the order ID. Let's talk about instance variables and custom instance methods in a record. In a record, we cannot define the instance variables. We can only define the custom instance methods. So let's see what is the use case where we need to define the instance method in the record. This order record has product quantity and its price. What if I want to calculate the total price of the order? So for that, I need to create the instance method named as calculate total price. So using this instance method, we can get the total price of the order. So in the main.java, I am going to make the changes. And I want to display the total order price. So here we can see that total price is calculated, and we can also define custom method to display the order details. So let me do one thing. Let me generate the toString method first, and then from the toString method I can copy this, and I would create my own method named as display order details. So it's done. And why I'm doing this? Because in the toString method I may have the requirement that I need to display the order ID only. So that's why I can create the custom method to display the complete order details. Yeah, so here we can see that the complete order details are displayed here. So we can do one thing. So instead of returning the order details, we can print the details directly here in the method. This method is not going to return anything. So I'm going to replace string with the void. Now in the main.java, we do not need to call this method inside the system.out.println. Yeah, so here we can see the entire order details. That's it for this video. Please don't forget to like, share and subscribe. Thank you.